work on our backend test coverage. This was way down at one point, and I've got this up to 92 and climbing. I've got two more modules that have some little bit of work to do, but just ran into a couple of weird little testing things that I'm trying to work out. But getting our test coverage up, it's pretty important to um, keeping our game solid, and if we track down bugs, they're a lot easier to fix without breaking existing stuff, so I'm pretty excited about that. As far as our front end goes, the front end's coverage is okay. I would say about average, but we have a lot of improvement we can do there. That wouldn't be too hard, so we're at 71%. A lot of it is due to just having our tweening system. I just kind of built that out just in a hurry. Once I cover that, it'll be pretty well done. And I think here, yeah, we got most of our tests commented out because we're just working on some of these things in here. So the test coverage will jump back up just a hair when we just uncomment this code. So let's get back to it. We were working on our quad tree, and we have it splitting where we insert into the trees, but now we need to actually insert the, actually we already did that, so it looks like we can, so yeah, this is actually about as a quad tree that we're actually splitting it into quadrants. Now, what we need to do is we need to cover a couple of cases here. We need to, I think we got most of this figured out. Actually, I think this is going to be the bulk of our effort. At this point, we need to check to see if we have, if we split, and let's see here. I'm not going to draw with my hands because you can't see me, so I've been doing a lot more work on my laptop lately, so I haven't been able to use the webcam. So if you say new, guy here, let's see here, toolbox. Woo, that's fun. Okay. I think if we get, actually, I want to use the pencil, and if we could just sort of, dang, this is hard to, so now, so if we grab a couple of, so say here's our game board. We drop one here, and we drop one here, here, and here. Then our quad tree, so if we go here, as soon as we get on the fourth one, our quad tree will split. Right, this is what it does right now. It does this, and if we grab here, if we did like 1, 2, right at that point, it would actually just split here. This is what we have working right now, and it'll just keep going until we go about 5 deep, which is great. Now what I want to do is I want to make sure that if we have a unit that actually kind of straddles, make it a little bit more representative here, so because our lines are pretty big. So if we have one that's like straddles here, they should show up in both these two quadrants. And so if we did something like this, so we've got 1, 2, 3, 4, 1, 2, 3, 4, and we'd hit 5, it would actually still split on both of these. Like so. So it would actually split here, like this. And so in this case, these two would live in both of these quadrants, and these two would live both in these quadrants. And so we got to write a test around this and see that that's actually happening. So that's the plan. So now let's look at what we got here. So if we say right now, I'm going to say private, actually, test should include items that straddle quad tree borders. Okay, so here we're going to set up our add. Actually, this is kind of ridiculous here. I'm not sure why the compiler didn't complain about that. And so we're just going to trim this out a little bit. So now it should still run. So I'm going to grab, we don't need this anymore because I'm actually removing anything. And so if we grab this, and so what's going to happen is it's going to split at, let's see here, it's going to split at 800, so 400, like 425, actually 450. So we want to drop all of our pieces at like 445. So here, 445. And so also 445. I'm just going to increment this by like 10. And this should straddle both. So we're going to do 2, 3, 4. This will cause it to split. So 2, 3, 4. And this will be 100, 110, 120, 30, 140. So now, when we validate our tree, I think we have, I'm going to get our quad tree node here, and at this one we're actually validating how many, right? So we're going to say is validate the tree at 0. It's going to be our first one because we're all in the first quadrant. Well, first if you start, I'm calling it first because of this. We're going to call it 1, 2, 3, 4, even though it's 1, 2, 3, 4, but I'll just look at that. I'll just say we're concentrating on this quadrant here. So here, we're going to have all 5 live in this area. That might not be true, but we'll find out. Okay, so here, we don't really care about the area, so we can just stick with that. It should include 5 of these items. Now we should do the same thing for 1, so it should be this side. And we should also get the width should be 450, or the x for 450, just want to make sure here. Yep, and that should have 5 as well. So let's run this. Alright, great, it failed. And it was 4 and expected to be 5. So make sure that they actually show up. Yeah, it should be in there. Because in our go to 380. Okay, so let's find out why this is not happening. So we're going to just comment this guy out. So we're just running the one test. And what we're going to do is we're just going to just trace so we create a new tree and then insert into trees. So we're going to trace leaf area X. Okay. We've got a lot of that going on. Oh, so we got lots of tests going on. Okay, we haven't commented all these. Still seems like a lot. Okay, that is a lot. So, curious. We are just putting a quad tree node. So I create a new tree. So first of all, when we add, we create a temporary tree, then we split the tree. It's all this. And then we insert into trees, which is this. Is that what we have? Yes. So, I'll trace leaf area X. Okay, so that doesn't give us too much information. So we're going to say leaf data cast leaf to quad tree leaf, because the data, and what we need to do is we need to know this, and we also need to know like the tree. So I'm going to insert it into tree so branch area X. Should be enough for us to track down which one it went into. Okay. So it looks like it got put into all of them. So let's just double check that here. So this is 450, 380, 380, should be 0 and 0. I'm just going to pacify it for now to see if that's truly the case. It failed, so that's good. Oh. And I think, okay, so that passed. So it is putting things in the right spot. So what we can do, I want to do this a little bit better. Leaf count. Tree 0. Four. Tree 0. I don't really want to worry about validating the width and height anymore because I already do that. So this is 0 and 0. But the question is, we're missing a $50. What's strange is that it looks like it should be working, but according to this, the data shows that it's working. But the test is showing it's working, but the trace is very different. And that's what's interesting. So let's dig into it a little bit. So what we're going to do is we're going to actually going to change this back. Three, four, 3, 4. 1, 2. You know what? I don't think I need to do that. I already got the data. So what we can do is we can say assert r equal. Let's say data.value is equal to cast quad tree 0. All right. And 201 expected value 4. Quad tree node leaf. value. Kind of excessive there. So invalid cast. Quad tree node, tree 0. Leave here. To me, cast deep. So that'll give us a little bit more detail. So we have cast. Well, what is it then? Tree 0. Tree. So here, 0, right? So that's a quad tree. Oh. So if we, that's awesome. So it did break it down into 2 smaller trees. So this is really good. This is actually good news. So if we say tree here, cast tree 0, quad tree. Comment that out for now. $197 said it was at 0. So this one, in this case, would be 2. No, it would be 1. Darn it. 1 and 4. Or 1 and 3 would be this. Which I believe, yeah. So that would split down. Again. So what we need to do, this is actually an amazing validation here. So let's undo this. So what happened is that it split. And what we're going to do, we're going to assert is type tree quad tree. Readjust here. Quad tree. Come on. My mouse pad is stuck. Quad tree. And so that should be correct. Comment this out. So here, I think this was Yeah, this is an array of quad trees. Yep. Okay, so we're grabbing the first one. So we're here. So we're grabbing this one, saying this is a quad tree. And then we're grabbing this one, which is saying this is a quad tree, which we don't want. We want this one. And then this one's probably going to be split as well into a quad tree as well. So what we're going to do is we're going to duplicate this line, and we want the one again. So one, and I think this one here is going to be this is going to say empty array. We might need, let's just trace out the trace actually just do trace tree sub1 area x plus. I wonder if there's a way we can do this. How smart is this? Public function toString string return foo. Trace tree sub1 dot area. Let's try this again. And in the meantime, we'll do x y space. Perfect. That is awesome. Okay, so we're going to do x. I think we can do x, y, width, and then height. Perfect. Okay, so now this will simplify this a lot. I'm going to say 0, 2, 3. Okay, so now, no. Okay. Width Okay, so at least it found the compilation error. There we go. So now we're a little bit more clear on our business now. So we've got 450. So we're not even in the right quadrant. So I think we want to do so because we're at 450. 650. So we're looking at this right now. 450, y is 80, yeah. And 650, 450, yeah. We're definitely looking at this area here. So we want this one. Hopefully it should be this section here, what we're looking for. So we're looking at 50, 250. 250 would be here. Okay. So now we want to trace tree. So we're at, this guy's at 445. So this would be 1. Cast tree with a quad tree length. Someone's at 4 as well. So what we're going to do is we're going to check this. Here, tree 1 is quad tree. No, wait. That's going to be true. So we're going to get effectively this. So we need to get another tree. 1. Now there's that. So that was true. And so now let's put this area out as we understand it. So this is not 250, 350, so we've broken it down way more. So this is getting a lot more clear. So what we can do is we can do similar to this. Okay. Actually, we'll just grab all of it. And we're going to paste that there. So we're going to tree area. This is going to be 50, 80, 200, 150. And this should have 0. Then we have 250, 80, 200, 150. Should have 4 because that one should split. 50 to 30, 200, 150. It should be 0. 250, 230, 200, 150. It should also have 4 because that should have split. So that failed. 231. Done. Let's see what this says. Darn. I was trying to be cheeky. One, two, three. Oh, yeah, because there's only split once. Okay, so this is correct. Okay, so here, because at this point, we're at 140, and outside of the realm here. So, that'll be correct through there. Grab this to make sure we're looking at the right thing. Lots of validation here. So here, and this is where it breaks down into the individual nodes, it looks like. So here, I'm going to validate this one, which is going to be 250, 80, 100, 75, 350, 80, 100, 75. This is going to be 250, 155, 100, 75, and this one's going to be 350, 155, 100, 75. And this will contain 1. Now, here, oops. We're going to take this. I'm going to get the tree at 3. And this one should be 4. And that worked. So then here, 2, 3, 4. So this one's going to be 0, 1, 2, 3. This is going to be at quadrant 1, 1, 1. No, that's not true. 0, 1, 2, 3. And that ain't fully true. Tree 1. see here. So we know that one's correct. Assert is type tree1 that is a quad tree node leaf. This might actually split even further, but I don't think it should. No, it definitely doesn't. So that succeeded. And so the leaf itself oh, here we go, invalid cast. Online. Oh, okay. Let's see here. So we're going to do this, and this is going to be a 3, and maybe give us some insight. So that failed. So this is going to be a quad tree. Let me say, do this, and that's going to be a 3. We're going to call this single leaf tree, and we're going to say assert or equal for single leaf tree at 0. That value, which would be necessary for a cast. Quad tree node leaf. Data value. So that succeeded. And so what we're going to do is we're going to cut this. We're going to say, I'll call this tree again. Now we're going to grab the first one, 3, 4. I'm going to do 0, 1, 2, 3. Yes, okay. 1, 2, 3. There we go, not. Okay. Line 223. I see. going on here? Odd. Assert are equal for tree length. Two 23. So the length is 4. So, oh, that's why. Duh. That's ridiculous. Alright. So now, once we have that in place, we get to check the other side, which should also exist. There we go. So that's that whole quadrantal area. And now, what we need to do is we should get pretty much the same thing. Darn it. Assert are equal 0. This is going to be 0, 1, 2, 3. Oh, wait a minute. Did I not read that correctly? I think I didn't read that correctly. So we're going to do assert is type. So this looks like this might have broken down even further, but we'll find out. Quad tree. Yeah, so we actually need to break it down even further. Quad tree. Just gonna take these again. I liked this debugging here. So here, we're at 350, 80, 50, 37.5. $400, 80, 50, 37.5. I'll actually have 2. 350, 117.5, 50, 37.5, and 400, 117.5, 50, 37.5, 4. This is a concern. So now, we're going to do this. This is going to be tree 1. 0 should be 0. 1 should be 1. So that succeeded. Now, type 3 is a quad tree. So that's true. So now we can grab this. See what's going on here. Wow, this is quite digging in here. So now, this is where we start getting into our straddlers. $400, 117.5, 25, 18.75, 425, 117.5, 25, 18, 400, 136, 25, 25, 18 and some change, 25, this is 136, And so this one's going to have 4 in it. It's going to have 3. So we're definitely going to be getting some straddlers here. So that's good. So now we can get our single leaf here. And this is going to be our sub 3. And we're just going to trace this out. 2, 3. So here that's cool. All right, so now at 1, 2, 3, we have 2, 3, 4. So it's actually matching this one. So they would be straddling. So that's awesome. Now I'm going to grab this one and see what this one has to say. No, that's not going to work. Yeah, that's going to work. $239. No. This is a very complex test with a ton of validation. So here, that doesn't even make sense. So that is a quad tree as well. Tree. And we'll validate this one. So we got some sort of cast problem here. Okay. 2, 3, 4. Is this a quad tree? Okay. So that passed. This should be a quad tree. But it's casting. So I guess there's 4 of them that live here, which is possible. So it's quad tree node leaf data value. So it actually does. 2, 3, 4. They're all leaves. So I'm going to make sure here we're at 445 and 110, 120, yep, 110, 120, 130. So it is actually correct. And that's 0, 1, 2, 3. So it's freaking perfect. So it's a bit hard to get here, but we got here. So this is going to be 0, 0, 1, 2, 3, 1, 2, 3. That's one gnarly test. There we go. Look at that. That's one major test. So we can comment out, recomment in, comment back in. These guys? No. I think this should all still pass. Yeah, that's all passing still. So what we need to do is we need to validate getting all out of point and stuff like that. So I wonder if this will pass. I don't think it will. It definitely won't now. Yeah, okay. So now we've got this situation set up. So it was actually, most of them were fitting in this one quadrant, this one fit in more quadrants, so that's fine. That's exactly how it's supposed to work. So that's it for today. We'll get more of this working tomorrow. This was one major piece that we got tested very, very thoroughly that it's working, and it fully is working. So that's it for today. Happy coding. See you guys tomorrow.